Okay, for that question you asked me, here's a diagram. Here's a semicircle. Here's an inscribed triangle. And we know that the distance of BC is equal to 10. And what I did was I did the midpoint of BC as O. So what we're going to do is this. We're trying to find, determine the angle that gives us the maximum area of the triangle. So by looking at the angle, we know that tan of theta is going to be equal to y over x. Therefore, y will be equal to x tan of theta. And we know that the area of the triangle is going to be your base, which is going to be 2x times by y over 2. So it's like 2 base times height over 2. The 2 will cancel out, so we get area is equal to x times y. And now we're going to substitute y as x tan of theta, so a will be equal to x times x tan of theta. And now in order to get the maximum area, we need to get the derivative of a, so a prime will be equal to, well, x squared, derivative of x squared is going to be 2x times by tan of theta, and we're doing a product rule, plus x squared, and derivative of tan is secant square theta. And in order to get the maximum minimum, we're going to let this whole thing equal to 0. And then we're going to use identities to expand the tan of theta and secant square theta. And that's going to give us 2x sine of theta over cos of theta plus x squared times by 1 over cos squared theta is equal to 0. So in order to get the common denominator, we're going to multiply this side by cos theta over cos of theta. So that's going to give us 2x sine of theta cos of theta, because we multiplied the cos of theta by sine of theta, plus x squared over the common denominator of now cos squared theta. We're going to let that equal to 0. Since we're going to multiply both sides by cos squared of theta, that will cancel out, and anything times by 0 is going to be 0. So we're now left with the numerator, and we can factor out an x, which is very important here. So it's going to be x bracket 2 sine of theta cos of theta plus x is equal to 0. So we know that this x value is going to be equal to 0. This is going to be very important for the next step. So within this bracket, we're going to solve for the x. So x is going to be equal to minus 2 sine of theta cos of theta. And when you look at this, that's a double identity. So I'm going to rewrite it right here. And let's turn the color to blue. So it's going to be x is equal to negative sine of 2 theta. However, from this value, we know that x is going to be equal to 0. So we let that equal to 0. And now we're going to determine the derivative of that. So it's going to be negative cos 2 theta, because we want to determine the maximum value of theta. So now we're going to divide both sides by -1 to get rid of that. So now we have cos 2 theta is equal to 0. We know that, you know what, now we're going to continue up here. We know that cos of theta is equal to 0, therefore on the unit circle, cos of theta is equal to 0 at pi over 2. However, on the equation we have cos equal to 2 pi, so we substitute the 2 back here. In order to get rid of that 2, we got to divide both sides by 2. So theta will be equal to pi over 4. So the angle that gives us the maximum area of the triangle is going to be equal to pi over 4.